All right. Well, again, good morning, everyone. My name is Ramy from Logix Academy. I'm delighted to be your host for this morning's session. We're super happy to have with us this session be a partner session with the University of Ottawa and led by Andrew McDonald, who's a Logix ambassador and just a great STEM expert in this space. I know Andrew's an educator, worked in a lot of outreach initiatives. I know worked with Kids Code Jeunesse in the past and supported a lot of initiatives in coding and robotics, looking now and supporting the outreach initiatives and teaching even with the university. So it's so wonderful to have them on board. This session is in partnership to really bring the best of robotics and coding to all of you in Canada during this time period. Give you a little bit of introduction about Logix, and then we'll delve deep into the content for today. The session is being recorded and will be available for all of you after today on our YouTube channel under our virtual training series. So we'll be sharing the links to all that in the chat window here. Logix, if some of you are familiar with our organization, is a Canadian company focused on kindergarten to grade 12 STEM robotics and coding. We're based in Markham, Ontario, and we work across the country. We do have 3 divisions of the company. Our first division, Logix Education, focuses on robotics and coding and STEM solutions, the hardware, software, curriculum, and professional development for the classroom, and we work with districts and schools and ministries of education. Logix Academies are direct-to-student programs, both in the classroom and as well as at home, online, and out of the classroom, and through community partners. And then lastly, Logix Robots is our consumer products division. We have our solutions and products in retail stores and channels like Best Buy, Staples, Amazon, Chapters Indigo. So you might have seen some of our solutions in a retailer near you, or of course in your classroom. Some of you might be familiar with our products, ranging from Metata Lab to Dash and Dot to MBot, Cody Rocky, and of course Makerspace solutions like the 3D printer and laser cutter. And of course, now we're introducing virtual robotic solutions. So for example, Dash and Dot have a full virtual neighborhood. That's really cool to engage students at home remotely during this time period. So if you haven't learned about those, if you want to take advantage of some of the free virtual solutions during this time period, check out our website and remote learning, and you'll be able to see solutions for home, for school, and for districts there. At our core, we are very focused on curriculum. And Logix addresses 2 components of curriculum, our Learn to Code and Code to Learn. Learn to Code focuses on digital literacy education and computer science education from kindergarten all the way through 12, aligning to international standards, while our Code to Learn focuses on cross-curricular and implementing and integrating these tools and resources in the classroom, in provincial curriculum, in math, science and technology, social studies, and arts curriculum. Professional learning and development is, of course, critical, and we're super delighted to have conducted and continue to conduct a wealth of training, whether it was in person or hopefully returns to be in person, or of course virtually, and then self-guided online as well. Working across the country has really helped us to connect with teachers and districts and schools across the country to allow us to see what teachers really need in terms of support in the topics of STEM, robotics, and coding. And that's really, really important to allow us to actually develop resources and support infrastructures that can help teachers across the country. And from our work, from all the way from Yukon to Newfoundland, we're really delighted to have created the Logix Educator Community, which anyone can join and be a Logix teacher to connect online, chat, converse, learn about what teachers are doing. We have discussions in different topics. Feel free to join and learn and share your knowledge and expertise as well. And then, of course, there's other levels like ambassador and innovator that folks can apply for on an annual basis. Again, this session specifically is part of our virtual training series, which we're so delighted to bring by through our many partnerships. Of course, being a Microsoft global training partner, we have lots of workshops on Minecraft. We have workshops on Flipgrid. There's a wealth of workshops on Teams and O365. So if you're looking for any of those, they're all free, all online. You can check out our website, logicsacademy.com/virtual training, and join any workshop you're interested in completely for free. And lastly, I'm super excited to have launched in partnership with Microsoft in Seattle, Minecraft Education Team, and Microsoft in Canada, the Canadian Storytelling in Minecraft Challenge for the month of June. So I'll show you a very short clip. Hopefully this plays and you can capture the audio here.
Welcome to Canadaville. Logix Canada is challenging Canadian students and teachers to tell their great classic Canadian stories using Minecraft Education Edition for a chance to win amazing prizes for their schools. Which classic Canadian story will you tell using Minecraft Education Edition in Logix Canadian Storytelling Challenge? Every community in our great country has classic stories to tell. Visit logicacademy.com/Canadian Storytelling and don't delay. Submissions are due by June 26, 2020.
So again, super delighted to be launching this exciting competition and challenge to allow every student to be able to download this world for free. They can use any version of Minecraft that they have, whether it's Education Edition or Pocket Edition, build a story and tell a Canadian story from their local community. We already have submissions from across the country, which is really exciting to see. Folks telling their stories, whether they want to tell the story of Wayne Gretzky or their story of, Niagara Falls, or, a story out in the West Coast or East Coast, anywhere across the country, really. They build the world, they share the story through video and submit it online. And our plan is actually to share all these stories in Launch for Canada Day. So what a way to recognize the country's history by having students share their voice and their stories and share it with the world. So any individual student can participate, groups of students, or teachers with their students can participate, and some fantastic prizes. There's over 3 prizes of $30,000 each for their school that they can win, even if they submit as an individual student, of tech for the whole school. So make sure to encourage your students to participate. And without any further ado, again, I'm very excited to hand it off to Andrew, who's going to lead us. I'm without a doubt, very confident is going to lead us in a super hands-on and exciting workshop all around using the Microbit in the classroom and engaging students in robotics and coding. So again, I'd like to introduce Andrew McDonald from the University of Ottawa, and look forward to learning alongside.
Yeah, thanks very much for that great introduction, Ramy. I'm excited to be here to be able to share about using the Microbit in the classroom, and to share some cool updates that we've seen over the last few months in terms of ways that we can use this in the classroom as a teacher in the classroom. I'm just going to present my screen. So hopefully everybody can see that now. We've got our nice big. So as Ramy said, that I'm from the University of Ottawa, part of the Maker Mobile team, and I'll talk a little bit more about that in a few seconds. I guess first I wanted to acknowledge where we're located. Here, I'm based here in Ottawa region, and I know all of you across Canada are maybe thinking about the things that are happening in the news, and so we just wanted to acknowledge the Indigenous people of this region. So we pay respect to the Algonquin people, who are the tradition guardians of this land. We acknowledge their long-standing relationship with this territory, which remains unceded. We pay respect to all Indigenous people from this region, from all nations across Canada, who call Ottawa home. We acknowledge the traditional knowledge keepers, both young and old, and we honor their courageous leaders, past, present, and future. So if you wanted to take a moment to just think about the people in your region where you're located, we can do so. So in terms of our time together today, I wanted to sort of take away 3 things from what we're going to talk about. So I'm going to talk a little bit about links to curriculum. So that's specific to here in Ontario, but again, they're we know that the links across Canada are very similar. So depending on where it will go into your grade level, we can chat about that later. We're going to explore the MakeCode platform and how we can use this to support learning in the classroom. Again, sort of say math classroom, but again, all of these ideas can be transferable to other areas. And then I've got a few takeaway projects we're going to create a few together. And then I've got the slide deck, for example, is yours to, we'll send it out to you as well. And via the recording, and as well, if you wanted to have a copy of the slide deck, we have no problem sharing that out. So my contact is at the end, and we can, we'll get it to you if you want it, type of thing. But first of all, let's just talk. I said I'm from the Makermobile. So who are we and what do we do? So we're part of the Faculty of Engineering at the University of Ottawa, and we've started off in September of 2015, and we're bringing technology into schools, communities, to get young people and excited about creating, about problem solving. And as you can see, we've got a truck here. We've actually got 3 different vehicles. So we go around to different locations within the region and across Ontario and Quebec to be able to support those students in their learning. And we know it's nice to be able to get that hands-on experience with coding, with robotics, and then encourage that creativity, the problem solving for students. So some of the workshops that we cover, a lot of them there, and if you're interested in learning more, we can share about that. But on with the show. So some links to the curriculum in the Ministry of Education document. There's different strands of the math curriculum: the number sense, numeration, measurement, geometry, spatial sense, patterning, algebra, data management, and probability. And so those go all the way from kindergarten to grade 12 in terms of, the different expectations that we have that we can learn about. And we can see how coding and robotics can hit into these at various levels. And I'm going to showcase a few of the areas that we can have the Microbit fit nicely into our strands. And then in terms of the mathematical process, or we can see how this is very linked with coding in terms of what we've talked about. If you're very brand new to coding, or if you've done a little bit of coding before, you'll see how this math and computer science are linked together. So in terms of problem solving, connecting, communicating, looking at strategies, and reflecting is all part of both the mathematical process and computational thinking. So it's a great way for us to link these two together. So some of you might be wondering, what is a microbit? If you haven't seen a microbit or ever played with a microbit, please let us know in the chat, and then I know what level people are at. If you've played with a microbit, please also let us know, just to say yes, you've played with one, or you haven't, or just so that we know, so I know at what speed I can go through some of these activities that we're going to do together momentarily. So a microbit is a small little computer. So I have one here. Oh, you can't. It's a darn virtual background. So small little one, it's about the size of, I'd say, half a credit card, very small, but it's packed full of really, really cool stuff. So first of all, it has 25 LEDs. Those are red LEDs, so you can light them up different orientations. You can scroll numbers, scroll characters across there. It's got 2 different buttons. So on the left and the right side of the Microbit. And then on the back, it's got a lot of sensors. And so it's got a compass or magnetometer, so it has the ability to measure magnetic fields or tell direction. It's got an accelerometer, so it will know its orientation in 3-dimensional space. It has this edge connector for accessories, and once you're able to connect things to it, the world is open. It's amazing some of the things that you can do and you can create with the Microbit. So it's sort of that expandability option, which is really exciting for when kids start to explore more with it and create and build with it. And so at night brings that sort of like coding and just getting started to bring that physical world and connecting them together to create different things and different learning experiences. So in terms of the coding language that we have, it's block-based, or one example that I'm going to show you is block-based. It does have other languages that we can explore with. We can use, so we've got blocks here, we've got JavaScript, we got Python, for those that have played with MBlock 5. A lot of different opportunities that people can explore with this. So it's good in terms of that low floor, high ceiling opportunities in terms of coding. So in terms of what some of the language that we have for the block-based code and how that will relate sort of to math in what we're talking about. So we're able to sort of set a particular value. We're able to change that value. We're also able to display a number, as I mentioned, or a string. And we're also able to plot or unplot things. So we're able to show certain LEDs on that screen light up or not. And so we can use that, again, thinking about math and those types of scenarios. And then in terms of mathematical operations that we can do, so we've got the basic arithmetic expressions, so adding, subtracting, multiplication, exponential. And then we can think about some other integer functions, so rounding, off, truncating, picking a random value, minimum, maximum, absolute values. And then we can get into some real numbers, so taking square roots, looking at trigonometry, so sine, cosine, arcsine. So really we can go far with this, and I'll show a few examples as we progress, depending on our time. But again, if you want these slides, I'll be happy to share them with you. And then we have when to do it, so where we can start this. And so at the beginning of our program, we can do this, and then we can use some of those buttons, or we can use some of the different aspects of the sensors that we have available to us. So it's, on shake, different things like that. So the first program that I wanted to, there's 2 programs that I wanted to show to you, is doing some very simple sort of math counting problems with our buttons and the onboard LEDs. And then we're going to try to do some things with the onboard sensors. I might not be able to have time to go through all of them, but at least I will share those ideas with you, and you can definitely go and explore with those later. So for those of you, we're going to do some new on sort of using Teams in a web browser, because I'd like for you to follow along if you would prefer, or if you'd like to follow along. What you can do is just take your web browser and put it on the side, either left or right side, doesn't really matter. and then sort of have teams so you can see me being able to showcase what I'm doing. Right. So the first project. So I'm just going to go over to makecode.microbit.org. So just write that in the chat, unless someone beats me to it. Oh, I think I wrote it twice. Sorry. So yeah, if you want to head over to makecode.microbit.org, and so that is the main platform that the Microbit uses, or one of the main platforms that Microbit uses to create their projects. So I'll give you a couple of minutes to get into that. And if you need me to slow down, just let me know in the chat. So again, we've got our make code here. I'm just going to take 2 seconds just to scroll down. They've got lots of tutorials, lots of live coding sessions that the make code team has done during this stay-at-home period. Tutorials in games, fashion, music, toys, science, different tools, so exploring each one of the sensors, looking at going beyond blocks in terms of JavaScript, and then also looking at sort of behind the hardware, which is also fun to explore and learn more about, and getting into some science experiments with it. So I'm not going to go through any of these tutorials with you. I'll let you explore on your own. And if you have any questions about any of the tutorials or getting started, please feel free to reach out at any point as well. That's what we're here to do. And so if you're all there, or hopefully you're all there, if not, again, just let us know in the chat. We're going to create a new project. And then it's going to pop up and ask us to give us a name for this project. So we're just going to say simple counting. So, and then we'll click create. And so what that will do is it will create this project for me. And for those of you that have done anything with Scratch or any code, sort of block-based coding language, you might be familiar with some of these things. But I'll just take a quick second to introduce you to the platform. And so on the left-hand side is our simulator. So that's where we can see our code. So we don't have to have a class set or individuals microbits for each one of our students. We could just have a few that we can share around. So once students have explored, they've tested out in the simulator, and they said, okay, I'd like to download it and see this in action, then they can sort of borrow the class microbit to do that. And the great thing about this is the microbits are, they only have one program on them. So a student can explore, they'll save it on their computer, and then they can load that onto the microbit and explore, and then pass it on to the next student if they want to explore with them. Then in the middle, we have our Scratch, or our blocks, our coding scripts. And you can see that they're all different colors. So if you're trying to follow along and you get lost, just let me know in the chat, or you can also see within the in the coding window over on the right-hand side. So again, this is where all the coding happens. So I'll just drag and drop and be able to show different things happening here. And so again, for this project, we're just going to do a simple counting project. So we're going to need a way of keeping track of something, and we're going to probably want to display that so we can see how many times we've, for example, pressed our button. So there's sort of three things that we're thinking about then. We need to press the button, we need to display a number, and we need to keep track of the number of presses. So we're going to need to, I guess, first of all, we'll go into input. And so that is where our button presses are. I'll just drag that and I drop it right here. So that's our button press. We need a way of keeping track of our button presses. So that is something called a variable. And for those new to variables, so a variable is just like a container that holds things. And so I always explain that as a sort of a lunch box. So the students have a lunch box. It's a container that holds your lunch. Every day it might change, or you add things in it, you take things away, but the container that is the lunch box stays the same. And so in this case, we're going to have pressed, which is the number of presses. And so I'm going to use all of these 3 blocks at some point in my project. So we'll start off with our set pressed at 0. So I'm just going to drag that and drop it into here. So you'll see that the, I'm just going to make this a little bit bigger. So you'll see that as I was bringing my code next to this on start, it will highlight yellow. And also it gives that little bit of a shadow to tell you where it's going to go. And then once it clicks in there, you know that it's set. So we're good with this one. So at the beginning, we're going to start with the number of presses being 0, which sort of makes sense. We haven't pressed the button yet. And then we will, when we press this button, we can change that value. And so we go back to variables, change pressed by 1. And so now if I go over here, I can test out my project at any point. So it just takes a second to sort of gray out the microbit, and then comes up a color, and we know that it's ready. So if I press on here, great. We know, or we assume that the project is working. We're not sure. We can look at this and say, yep, the code makes sense, is logical. But in terms of actually seeing anything on the simulator, we have yet to do that. And so we'll do that right now. In our forever loop, we can grab a basic, and we're just going to show a number. So we'll just drag that, and we'll put that in there. And then we go to variable, and then we're going to see we've got this variable here. And the cool thing is, this is a new feature that just got released on Friday, is now it will show you where this variable is going to land, which is very helpful for when you start to get a little bit more complex in your coding, and you'll appreciate that, and your students will definitely appreciate it too, to know where that's going to drop. So, all right, so we've got our basic program ready to go, and so I'm just going to click on A, and there we go. We see it being updated. So each time I press the button, we've got our a microbit showing number increasing. All right. Is everybody following? Need me to slow down? Need me to review? So again, this is just a basic counting, and we can build on top of this. This is the nice thing about the microbit, is we can have this as a standalone project, which we can share. We can count how many people have, brought apples for today. So we can use this as a counting mechanism. So or voting. Lots of ways on using this in the classroom. So for data collection, going back to one of those strands in terms of data management and probability, then we can look at data management through using the microbit as a way of asking questions. Those polls that we have students running around the school asking about, then they can have questions where it's an A, a B, or the cool thing as well is on button A, B, we can have A, B together. And you'll see on the microbit simulator that it will pop up with a little additional block here, just because it's hard on the simulator to press both A and B at the same time. I'm just going to put this back to here. And I'm going to go back. So now that I've created this program, I can download it onto my computer, or I can download it directly onto the microbit for that use. So I'll do a couple more, or I'll do one more, and then I'll show you how to download that. So if we click on Home, you'll go back and you'll see that you have your program right there all ready to go. So one thing about coding with the microbit is it stays in the cloud. So you want to make sure that the students either save it to their computer or save it to their Google accounts, so that if there's lots of students using the same computer, they don't lose their projects. So I'm just going to make a copy of this, and the way to make a copy is if I click on My Projects, you'll see all of the projects that you have. Right now I only have one, but if I click on this, I can click Duplicate, and so this is going to be complex code, complex counting. So now I've got this one. I just click on that and open. And so now I have that ability to take this and I can now add something to it. So again, I can show, I'll show you how to duplicate in 1 second when I duplicate this project. So now I've got this project. So now I've got the complex coding. And so what I'm going to do is I'm going to make it, instead of just button A, add something to it, I'm going to use button B, can also do something. So if I just right click on button A pressed, I'm going to duplicate, and then you'll see that one of these will be grayed out, which means that I can't having like competing arguments. And so I'm just going to go to on button A, and I change this to B. So now I have the ability to count by 1 with this one, and I can either subtract with this one, or I can count by 2s. And so now we can start to think about using this to count by 2s and count by 5s, for example. So I start off at 0, and then I can, 2, 4, and then 4 plus 5 is 9, and then you can start being creative in terms of like, how do you get to a certain number, or you can start to be, that skip counting opportunity that we have. And so if I just jump back to this, I can go back to my example here. So how can you get to a certain way, or other things on different ways to get to a certain number, in terms of, one student might be experimenting one way and one other student might be experimenting in another way. So a great opportunity for students to sort of experiment, and then they can reset their microbit and try it again. They just start over, seeing if they can get to a certain number, based on, I've touched A 3 times and B 2 times. What number did I get? And then try to challenge other students to get to that number as well. So that's my next little one. So I'm going to go back to home. And so for those of you that would like to duplicate, so you click on My Projects or View All, and you'll see this list of projects. And you'll see a little, I'm going to select this project. So I can select 1 or 2 of them, or one or the other, sorry. And so I'm going to select this complex coding one. And then you just click Duplicate. So in the top right-hand corner, there's a duplicate option. And so this one I'm going to call complex counting, adding, and double. So if I just click Duplicate, and now I've got a third one here. And then I'm just going to click Open. I can either open it in a new tab or just open it in this tab. I'm just going to open in this tab. So these are some little updates that they've MakeCode has done over the last little while. So for those of you that have played with it before, I'm trying to show some new things that they've done as well. All right, so the next thing, so I've done some adding, and then I also want to do some doubling. So if you think about, so let's change this back to 1. So I can just go count by 1s again. But then if I wanted to double, so the way to double something, well, there's actually a few different ways in math to double something. You can either add itself to itself, or you can multiply by 2. So there's so many different options, and this is where you can sort of give the challenge to the students that you would like to have a program that will, count by twos with an A and then double it with a B type of thing. And so I'm just going to use the variable itself and put it back in here. And then so changed pressed by pressed. So it's taking the value. So again, I'll click it. So it's now 2. So if I press B, it's taking the value 2 and adding it to 2. And there we go, 4. So again, fun little opportunity to explore counting with the Microbit. So those are 3 sort of nice intro activities to explore with the Microbit. Other options in terms of that single digit, instead of having it when it gets to a certain value, you can have it sort of reset to be 0. So you can have maybe 3 microbits, and you're looking at your ones position, your tens position, and your hundreds positions, for example. And then once you add a value, so you're at your ones position is at 9, you press 1, it goes back to 0, and then you use your tens microbit, you press 1 on. So again, you can have this as you can make this as a manipulative, or you can challenge your students to get there. And again, you can see the code is right here as well. So the adding and doubling, I can go back and do that just quickly. So here we're on start, we're pressing or setting the number of pressed to 0. And then when I press A, I'm changing the value of the variable. So again, I'm holding that that value in a variable called pressed. So I'm just changing that by 1. And then, so forever just showing that value. And then this doubling over here, so what it's doing is it's taking the value of pressed and it's changing it by itself. And so it's essentially adding. So this change is adding that value. So for example, right now we have a value of 2. So if I add this another, so we have a value of 3. So it's going to take the value and change the current value by the current value. So taking 3 and adding it to 3. So we get 6. Hopefully that helps. So the next little, and yes, you can add comments in the code. So if you just right click, you can add a comment. So here is the doubling. We are adding x to the value of x. And there we are. So x plus x is the same as 2x. So we end up with 2 times x type of thing. And this is where we can write our math out or that sort of thing. And so you can either comment on individual blocks, or so yeah, you can comment on both of these blocks if you wanted to. So each block will have a comment. And if you wanted to minimize it, you just press this arrow and then you click on it again, it's still there. So setting the value to 0. And then this is like start the there we are. Then what? But once you have more and more comments, then yeah, it starts to get a little crazy in there. But then you can just minimize that. And then if you accidentally make a comment, so here I can make a general comment on this project is to And then again, I can minimize it and it's there. But let's say I add another comment and I'm like, oh, I don't want that. I can just delete that out. All right. So the next thing that I wanted to do is, and if I've gone too fast, again, the slide deck is available with the code. Also, I've got links to built out code as well. So you have, just click on that link and it should go to some working code for you to explore, change it. And the great thing is, like, once you've changed it, it doesn't change the original code. So if you lose it, you can come back later and do that. So the next little thing that I wanted to show you is how you can use this in a classroom. So using Microbit Classroom in remote settings. Now for this one, you do have to work synchronously with your students, but you can be remote or you can be in person. So we'll see how things turn out in September. But if you're working with students, this is a wonderful opportunity to sort of peek over their shoulder as you think. So I'll try to go through this quickly and then we can demo it. I know that we've only got about 15 minutes left. So again, it's the ability to sort of push out some code and to collect those assignments at the end, which we know that sometimes it can be hard to do. Well, I guess that second one is that collecting the assignments can be hard to do, whereas this, they're sort of working in a closed off garden. So they are working there, then they submit that back to you virtually. So again, you sort of go to the launch page, you launch your classroom either with a ready-made project that Microbit has on their website, or with a blank code, or with no code, or with some code that you've already created. So you have that ability to do that. And so what I'm going to do is I'm going to go and demo it. I've taken some screenshots for you if you want, but what I'm going to do is I'm just going to do a demo of it. So the classroom website is here. I'm not going to share it with you because I'm going to create one as a teacher, and then I'll have you join as a student in hopefully in a minute. So we're just going to say math activity. We're going to use make code and launch the classroom. And the nice thing is it gives you the 4 steps on how to run your classroom. So you need to complete your code setup. You need to add the joining details, so share it with your students. You can view the live students' code and then save the classroom. And the instructions are just like editor, dashboard, student code, save classroom. So these 4 things. So we've got the editor, so I'm just going to head over there. So it looks exactly like our make code project. So I'm just going to grab a ready-made project that I have already. So the nice thing is, if you already had a template that you wanted to the students to work with, you can just drag it and drop it. So I've got a little more complex code that I've written in there for you to experiment with. But again, you don't need to explore too much with it. But it's just to show you that you can have this there. Now I'm going to share this code with students, so I just click on that. And what it does is it pushes it all out to the students. So when they join the classroom, they're able to get that. Then I'm going to go to the dashboard, and this is the bit where you can now join. So I'm going to copy this URL, and I'm going to put it into our chat. And then I will give you a few minutes to join based on these credentials. So on your end, on the student side of things, you will see a classroom name, and it's randomly chosen based on a color, an animal, transport, and an object. And then there's a specific pin. And so these are created at this moment. So the one thing is, like, you can't create a classroom and then have the students join at their leisure. It's not like Google Classroom in that sense, or Microsoft Teams, whatever you're running your LMS through. This is a sort of instant classroom sort of thing. And the nice thing is you don't have to worry about students like login information. You don't have to worry about randoms coming in as well. So all these sorts of things in terms of security, they thought about that. And in fact, like Microbit doesn't save any of your programs or anything like that. So that's for you as the student or the teacher to save those. So nothing is saved.
Andrew, does this class, sorry.
Go ahead, yeah.
Does this class stay permanently with the students' names in it, or you just create a new class every time you want to?
Yeah, you would create a new class every time. So that is, yeah. So that's the sort of like there's pros and cons to this type of idea. So students necessarily like they can't like leave their work and then come back to continue. It's an instant, and you as the teacher, you can close once you close this browser down, then they're done type of thing. And so but the nice thing is then the students, we can teach them to save their items, we can teach them to save and come back later to explore in the MakeCode environment by themselves. But this is a good way for you as the teacher to sort of create this and then look over their shoulder essentially. And so we've got 6 people. But yeah, if you have any other questions, please feel free. Hopefully that answered them.
Yeah, no, that's great. So they're still just saving their code either to their desktop or the cloud, right? All the time.
Yes. Yes.
Okay, thanks. Thank you.
No problem. So we've got 6 people as joined. That's wonderful. And so what I'm going to do is I'm going to click over on the student code, and then we can see how we've got people are in progress. And so I can just click on different students to see how they're working away at their code. And essentially, like, it's live, it's like real time. So I can see that Joanne hasn't done anything. I see that Joe hasn't done anything. So we can see how people are working through here. And if you wanted me to, like, so yeah, just to go through this. Joe, do you want to do something? Do some creative coding, and then I want to send it out to people. I want to show, so Cheryl, nice, good idea. So changing the number X by 1, changing the number, great. So we can see that Cheryl is like, as she's going through, I can look over her shoulder. So if she says, you know, teacher, I'm completely lost, I can sort of come over, and I don't necessarily have to, you know, and this is, you can use this in the classroom setting or virtual setting. The nice thing about the virtual setting is now I don't have to worry about, like, can you share your screen? No, not that tab. All the other tab, like, you know, it's 20 minutes of technical difficulties just to see that they've, you know, got something in the wrong place or something like that. So, and then the neat thing is, if people are struggling or they don't have any idea on what they're doing, then you can take someone's code and you can push that out to someone. For example, we've got, you know, Cheryl's working away at doing some things, looks great. And so if I say, oh, I wanted to take Cheryl's code because I see that, you know, Joe is having some difficulty. So I can take her code and I can cancel all these other students and just send it to Joe and say, send code. And so what happens is Joe's code, what his current code was, and it could have been, you know, he went down the wrong path, or he didn't have a starting point yet. I could just send it to him and it will completely erase what he's done so far. Looks good so far, Cheryl? And then, so the neat thing is now, you know, let's just pretend. So if someone wanted to click, they're finished. Please. So again, instantly, so Joe is finished. He's not happy with his result. So if you look at the finish, there's like 5 emojis that will come up, and it will say, you know, if you're happy, sad, joyful, those sort of things. And then you can say, okay, well, you know, Joe did a good job. You know, you need to fix up this here. So I can comment verbally, or I can send a message to him. And then I can then click on the little arrow or the little pen icon next to him and send it back to him, so he can then continue to experience it. So if you're frozen, that might be on your side of things. I'm not able to sort of freeze or unfreeze your, that could be a browser issue. You can reload your browser if you want, and maybe that might help. So just for matter of time, what I'm going to do is I will close this down and then go on to the next part. I just wanted to show a couple little things, and then if there's any questions, I know we've only got a few minutes left. So I can go over here to Save Classroom, and so I can end the session. So what that does is it stops all of the students from doing their activities. So what I can say is, okay, make sure you've saved your project, that you can come back and work on it later. I'm going to download. So you can download your classroom HTML file. And what this does is it means you can upload it back into this particular area. So you can resume your classroom. And so you just open it in your browser. It's an HTML file, and just continue off. The students will have to rejoin using a different code and different PIN. And then they just, in a drop-down menu, pick their name, and they'll go back into their original code. You can also end the session. So I'm going to do that. And then it will prompt me, are you sure you want to end session with downloading the file? And so I can download that file, and that will help me for next time when I load it with my students. All right. So it's going to end session. So now all of you will have seen the experience from the student's point of view, that it will say, like, the students, this is no longer, this session is over. And so you'll have lost what you've did, which I'm sorry about, but I do have finished code that I can send to you later. So that's great. So again, like I said, I've got step-by-step on how to use the Microbit classroom for you. So in terms of next steps or some other things in terms of in using Microbit in a math classroom, so we can use the onboard sensors, and I've got a couple of quick examples. And for those in the National Capital Region, we've got, and when we're back able to connect again, we'd love for you to come swing by the office, or we can somehow coordinate. We'd love to be able to drop off some of these experiences for you. So our first one was looking at a Trendle wheel. So for those of you that you might have this in the math, in the PE classroom, and we can use that. So I laser cut some circles and put Microbit on the edge of it. And so when the Microbit comes up to the top every time, because of that accelerometer, it will start counting. So I laser cut these, or my colleague laser cut these, to have circumference of 1 meter, and so we're able to use this to count off steps or number of meters to a certain object and that sort of thing. And so then you can use one microbit as a compass heading and one microbit as you're going in a certain direction. So some great use of angles and distance measurements. So there's some code there for you. Again, I won't go through it, but happy to do that at a later date. Another one, because we have the ability to use the angle measurement. So this first activity, we were seeing how far that X position along the bottom, how far away the tree was from us. Now we can use the microbit to tell us that angle. So this particular angle here, we can use some creative coding to find out and just strap that onto a toilet paper roll, which we know a lot of people have nowadays, or a ruler, a meter stick, anything really to be able to do to make a clinometer is, I had to Google that, but that is what it's called, to tell us the angle from the horizontal. So again, those are two little activities that you can take the microbit and the onboard sensors to be able to use with it. So yeah, so if you could, if you fill out the survey, we'll make sure to send along these slides to you. And Joseph just put a very large link in the chat. And yeah, we'll send the slides out and I'll open it to questions for the last couple minutes.
Well, as everyone's thinking of their questions, just wanted to take a few moments to really thank Andrew for leading us in that awesome session, walking us through the resources available. I really like the ability to share and share the code. So that's really powerful, allowing sort of this anonymous sharing of code without logins and things like that, which is, I think, really useful and well thought out as a tool to get students to share their work. So yeah, if you have any questions, don't hesitate to either use the raise your hand function, unmute yourself, or if you'd like, put it in the chat and carry forward from there. And while questions are coming in, we'll be sharing links in the chat as well, so you have it. And just for those of you who are familiar with Microsoft Teams or may not be familiar with Teams, you can always come back to this link after and have record of the whole chat. So if you forgot the link for whatever reason, or forgot, the bit.ly short link that Andrew shared or Joseph shared, you can always come back here and access it in the future. It's available for you in the future as well. Or you can always reach out to one of us. So again, please take a few moments to fill out the feedback that Andrew and Joseph have shared. As well, Andrew's kindly shared his email in the chat, so you can reach out to him directly if you have any questions. And then we're currently sharing some links around where you can access the virtual training series if you're interested in more workshops with Logix, and thanks to many of the partners. If you're interested to continue the learning, and of course the Minecraft challenge that we shared earlier. And actually, I don't know if some of you can actually code in Minecraft using MakeCode, the same programming language that Andrew just shared with the Microbit. So it's all kind of that block-based environment as well. So you can really get your students to enjoy the wonderful world of Minecraft through coding as well. And again, this session has been recorded and is being recorded. So if you have any questions or you want to just go back, reference a slide or anything in Andrew's presentation, just jump on the video. You can pause it, take it at your own time, and see what he went through there through the video. Again, I want to take a moment to thank everyone. It is 10:30 a.m. Eastern, so thank you so much for your participation. We thank Andrew and University of Ottawa for supporting this, and we really hope that you join us in future sessions and training sessions, and look forward to continued learning.